All right, so here we have L'Hopital's rule and the indeterminate form infinity over infinity. So we've been looking at 0 over 0, but it also works for infinity over infinity. So each of the limits is going to be infinity over infinity indeterminate form. And so in general, if our limit as x approaches c of f of x is equal to either plus or minus infinity, and the limit of g of x for the same thing is plus or minus infinity, then the limit of f of x over g of x goes to infinity over infinity, and that's the indeterminate form. And furthermore, x approaches c can be replaced by all three limits above again as c approaches from the right, from the left, infinity or negative infinity. And it can be shown that L'Hopital's rule applies to all these forms. Now, that means we're just going to be taking derivatives again. All right, so L'Hopital's rule for the indeterminate form 0 over 0 is also valid if the limit of f and the limit of g are both infinite. So that's both positive and negatives because you're going to get, positive or negative infinity. So what we can do is we can take derivatives again and then figure out if it actually will work or not. So sometimes, again, you might have to take several things. You might get, after this one, you might get infinity over infinity. Then the first derivative might give you infinity over infinity, but then maybe when you actually have to take it, or that's a g, the second time you might get like 2 over 1. So it all depends on how those derivatives look. It might take several times before you get to the actual number that works. And it's kind of like with the zeros, when we had x squared in the bottom, we had to go twice till we got something that worked. Same thing's going to work with infinity over infinity. As long as you're getting infinity over infinity, you can just keep taking derivatives until you get to the final answer. All right. So here we have limit of x approaching infinity of ln of x and x. Well, what do we get? Well, ln of x, remember, that looks something like that. Well, it keeps going up, but anyway. And so as you approach infinity, this goes to infinity. And x, well, that's going to be infinity. Okay. So we need to take the derivatives. So limit as x approaches infinity. Well, the ln of x is going to give us 1 over x. Derivative of x is 1. Okay. So this really is just 1 over x. So if we plug infinity into here, what do we get? We get 1 over infinity. Well, that's going to be a very, very small number, which means it's going to be 0. Okay. And so this one ended up pretty quick. It didn't take us too long to get to that point. And so that one is how it's going to work. And like I said, it's going to work exactly the same 0 over 0. You just keep taking derivatives until you actually come up with a number here and you can get a value. Okay. All right, so let's stop there and we'll come back for some more.